Hello everyone. Welcome to Robotics for All Advanced Python class. This is Ololali. Today we're going to learn something super interesting, which is called a tree. As you can see from my computer screen, I have a tree here. You might say, this looks like an upside down tree. I would totally agree with you. So this is a tree data structure. Before we start, I want to quickly go through some terminologies that could be very useful for this class. First of all, this is called a tree. And second of all, it's a binary tree. The reason why we call this a binary tree is because for each node, we have 0, 1, or 2 children. We don't have 3, we don't have 4, we only have 2. And each of these can be called a node. However, there are some really special nodes in a tree. This is definitely a special one. Think about this as an upside down tree. So this is the root of the tree. And we can see that there are some nodes that don't really have children. So those nodes are called leaves of a tree, because we know on a tree the leaves doesn't really grow baby leaves, right? They are the end of a tree. So those are called leaves. So if I want to implement something like that, how can I do that? As you learned from previous classes, we can make a class. We can make a class called tree. So how do we initialize a tree? So in this case, we assume we're making binary trees, which means it only has left and right and the data for itself. So that gives us some hint for the definition. Let's make a constructor for this class. We'll start with self, and we'll have a data that each node holds. And then we'll have left, and then we'll have right. And we will assign self.data to data, and self.left to left. And then we'll do self.right to right. Okay, that's great. But you might ask, okay, I know what's data, right? In this case, if we start with 1, data is 1. But what is left and what is right? So we can see that the left is 2 and the right is 3, 4, 5. Okay, let me do something interesting here. What if I just delete that? I just delete this. Is this still a tree? Yes, it is still a tree. Okay, let me go even further. If I delete this, is this still a tree? And the answer is yes. This is a tree because it has a root, and also it doesn't have any children, but 3 itself can be its own leaf node. So this is actually a tree. Let's go back. So we can see that 1 on the left have a tree, and on the right have another tree. So basically left and right are mini trees. And how about, you might ask, okay, then how about for 4, right? It doesn't have anything on the left, it doesn't have anything on the right. So in Python, we have this keyword called none. Basically, it means nothing. So let's assign left and right to default value called none. Basically, if I don't explicitly tell Python what my left and what my right should be, then it will just be none. Okay, so let's try to construct a very simple tree here. What I can do here is I can say, okay, let me make my leaf node right here. I can say my left should equal to a simple tree, the most simple tree, which is have data 2. And as you can see, I didn't put left and right here. That's because left, if I don't put any value, is just nothing. That's exactly what I want. And for the right, I can have tree with value 3. And then I put them together, I connect them to number 1, then we have a really good tree here. So my tree can equal to tree, and my value is 1. Now on my left, I don't want nothing anymore. I want my 2 tree, right? So I would put my left, which is my 2 tree here. And on my right, I will have my right tree, which is 3 in this case. Now, believe it or not, this is our mini tree. Okay, so that's really abstract. Let's find a way to print this out, okay? So I will just copy paste some code here. So basically what this does is to teach Python how you want to print tree. So basically when we print tree, we just print out the data, right? So I can do something like print. If I want to print out my left tree, I can just do that. After I run it, we'll get 2. That's not very interesting though, because let's see, I want to print my tree. Ideally, I'd want to print all the numbers, but right now it can only print out 1, which is just the number, the root itself. So how can we make a function that can print out the whole tree when we pass in the root? So let's try to work on this. Let's make a function called print tree. And of course, I need to take in a tree in order to print it, right? And the next step is, what's the minimum tree you could possibly think about? What's the smallest tree? You might say, okay, maybe 2 by itself is the smallest tree. But I'd argue having nothing is the smallest tree we can have, right? Let's handle that case first. So if my tree equal to nothing, basically you give me an empty tree, right? Then what should I do? Because it's an empty tree, I don't want to print out anything. So I would just return. The function is over. We're all done. And the next thing I can do is I can print out the data myself, right? Just like what we did here. We can do print my data, which is tree.data. Okay, that all look good. Then how do I print out my left mini tree and my right mini tree? The answer is actually part of the question, which is print the tree, right? If you want to print out your left tree, just call print tree for your left tree. If you want to print out your right mini tree, just call print tree on your right mini tree. Let's try that. So let me call print tree, which is the function we're actually writing right now, which is really cool. Let's say I want to print tree.left, which prints out my left mini tree. And then I want to do the same thing for my right mini tree. This is called recursion. Basically, things can be break down to smaller parts, and by solving the smaller parts, you solve the big part. Okay, this looks like magic, but let's try if the magic works. If I call the print tree function with the tree we made, what would happen? We can see that all numbers got printed out, which is amazing. But you might be wondering, okay, it's cool, but how does it work? Let me just break it down a little bit, just with some, let's walk through the code step by step and try to make sense out of it, okay? So when I first call this function, I call print tree with my tree, right? My tree is basically this node, the node 1. So let's just use 1 represent this node here. Okay, then I would check, is my tree none? It is 1, so it's not none. So we move on. Okay, if it's not none, print your own data. And the data here is 1. So we print 1, which is what we see here as well. And my next step is print the left tree. Okay, so basically what I'm doing here is I want to print my tree left, which is 2, right? In this case, my tree left is 2. So basically, I'm running the same function, but on 2. Let's just copy paste the same function, the same definition of this function, but now it's 2. Okay, is 2 none? Let's leave a little space here. Is 2 none? It is not, it's 2. Okay, then we skip. Then we go to the next line. We print out the data if it's not none. So here is where we print out 2. Okay, the next step is to print out the left tree of my 2. What's on the left of my 2 is nothing. So I do none, right? And then we can see that print tree, if the input is none, what we do here, we return. Return means the function is over, do nothing. Okay, then we do nothing. Then we say, okay, print the right side of our tree 2. What's the right side of our tree 2? It's also nothing. So we run print tree again on nothing, which we can see from here. It's also just return, do nothing. Okay, then we're done with printing tree 2 because we returned and go all the way back to print tree 2. Now we move on to print the right side of our tree. And remember, we're doing it for our tree 1 all the way back here. What's the right side of our tree 1? Is 3. So basically, we're calling this function on 3. Okay, so let's just do the same thing again, right? If I call the same function on 3, let me copy paste the same function. Is 3 none? Nope. So we move on. So we come to print out the data for 3, which is print 3. Here's where we print out 3. And then let's look at the left side of our tree 3, which is nothing. So we pass in none. And then we run the print tree again. As we know, if the input is none, we do nothing and just return. Similarly to the right side of 3 is nothing. So we pass in nothing. And we run the function print tree, which we know is just going to return when the tree is empty. And then we reach to the end, the function's over. We print out 1, 2, 3. So there's no big magic in there. If we go through line by line, then we can see it actually makes a lot of sense. That's the power of recursion. All right, now we can print tree. Let's do something fun. How about if I want to search a value in the tree? So I'd pass in a tree and the value. Okay, so how should I do this? Similarly, we want to be able to handle the smallest tree, which is basically nothing. So if you give me an empty tree, right? Let's say the value has to be an integer, then you should probably return false because the number is not going to exist in an empty tree. Okay, we handle our smallest case. And we can always check if my data right now is the data you're looking for, right? I can always check that. And I can use the logic we use for the print tree, which is I let my left tree to decide if the value exists. So I just call the same function on my left tree, on my left mini tree. And I'm searching for the same value, so I don't change that part. And I can do the same thing for my right part of the tree. And I'm searching for the same value. So basically, I say, okay, am I equal to the value? Is the left side equal to the value? Is the right side equal to the value? And now we have 3 values, but we only want 1 value in the end, which is, can you find this value in the tree? So the trick here is you don't need to find it everywhere. You only need to find it at one place. For example, if my value is 2, I only need to be able to find it in the left tree, and that's it. So in Python, if we want to put all the values together, and if one is true, the whole thing's true, we use something called OR. So now we return this one big value, which is if we can find the value in this tree. And here, let's not forget to return this value, which is very important. This is trying to tell the program, hey, you're done. You can return your value now. Okay, now let's run a couple examples and see if it works. Let's print out the result for search 1, 2, 3, 4, 5 in our little tree. If we run this program, we'll get true, 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 false, false, which is exactly what we're predicting. All right, that's everything for this class. I hope you enjoyed it and I hope you learned something. I'm excited to learn more in our class with you. Thank you and have a good day.